Hello there. We are going to jump in and do another one of these 128 battles. This one is again from last year's competition and again from the 128 head-to-heads, this time the afternoon session. So this session was done live by 4 pairs in the competition, so 8 contestants and everyone else did it offline. So we're going to work through this like we did with the last one, try and work through it as we go with the timer. Then we're going to go through and try and explain what we did if we didn't do that as we went, and try and make any corrections at that stage, see how far we can get. This case was written by Harry Gross. Harry is, I believe, current number 1 for the under 25s. He's currently number 8 seed for this year's competition. So they've seeded the top 8 so that they don't meet each other until the finals. And he's actually the person in the top 8 who is in my bracket. So this is my bracket. If you follow it through, if I get far enough and Harry gets far enough, I think it's more likely he will than I will, then we'll be against each other in the battle for the final 8. So as before, I've not seen this case. I've seen basic outline when I was trying to work out which case was on the live version for last year's 128 head-to-heads, but we're just going to jump in and start the timer. As before, we're just going to hide the answer codes so we're not tempted, as well as column F so we don't see what we get right. So you've joined university, as you can see, young lad, so university focused. You've made 50 new close friends. Your new friends haven't met each other. They want to understand the statistics between them by using Face Workbook. You can build up some pairings of friends and close friends. If someone makes a social media post, it was seen by their friends and the friends of their close friends. Answer the questions below based on the friendship status of friends. We do have bonuses this time. If a friendship counts as 3 normal friendships, you have some most friendships. Which person would have their post seen by the smallest number of people? And how many distinct triangles of friends are there in a network? 3 friends are a triangle if they're all friends with each other. And then our questions are, how many friends do each of the people have? Whose friend comes earliest in the alphabet, and we're giving a number based on, I assume it's this number. How many friends do the following pairs of people have in common? Pair of people. How many friends they have combined without double counting friends they have in common, but counting themselves? But counting, is that only counting themselves if they're friends with each other, or are they all friends with each other? I don't know, we'll find out. And when someone makes a post in Face Workbook, all their friends see it and all of their close friends share it so that their friends also see it. How many other people would see a post, excluding themselves? Okay. So I think this one and this one are very similar. So let's add in some columns here. Are these 2 lists the same? Let's just check these 2 lists are the same. So transpose will let us turn this into a column, and this will just give us an array like this. And if we wrap that in an and, it will be true if they're all the same, which they are. Cool. Number of friends, and bonus 1. So we want to count if they are that symbol. And then close friends, does it say close friends count as friends? Someone's close friends also consider their friends. Cool. And yet we can see Aaron, which is their example, has 11 friends, but we've only got 9. So we also want to count the number of these, which are this. So that should be 11 now. There we go. And then you can simply just change this to, what did the bonus say? 3. Who has the most friendships? So let's get the max value of And then we can look that up to find to whom that value belongs. Kara. Kara has the most friends. And we know that Aaron has 11, so it looks like that's working. Bam. 100 points. 5 minutes in though, so that's quite slow. Let's get going. Of the following people's friends, who comes earliest in the alphabet? Person. Right, let's get the name of the person. And let's get everyone's names. And we know they're in the same order. So we can also... How many are there? 50. We can also, let's just do it this way. Do this, because we know they're in the same order. In fact, we could have done that. There we go. Okay. And now we want to know if Aaron is friends with them. So we can find Aaron's index. So that's going to be this thing with X lookup. You can look horizontally as well as vertically, as opposed to having to use both types. There we go. So Aaron's number 1. So we can then just choose from this row number 1. That's not what I wanted to do. There we go. Let's pull both of these into here so they are easy to get to. And then we can filter this on this not being 0. I assume there's 20 questions. And we just want the first person because they're going to be in alphabetical order. There we go. Data table, column input cell. I don't know why the automatic calculations always seem to be off on these questions. Oh, you need the number. There we go. 3 for Aaron. There we go. Okay. How many pairs of friends do the following people have? So let's make a level 3 one. That's not what I wanted to do. Let's make a level 3 one. Person 1. Person 2 is going to be just pulled from this one. And then we're just going to do the same thing for person 2. So we're looking at Betty. Get rid of those. That's not what I want to do. I want to do this. P1, P2. How many friends do the following pairs of people have in common? So we want to know in common. We want to know that that's not 0 and that that's not 0. There we go. Let's Do they have any in common? Yes, they do. There we go. And then we want to do a sum of this. But you can't sum trues and falses because it'll just give you a 0. But you can use the unary operator, which is this double negative symbol here. And that changes, if you take the sum out, it changes all the falses to zeros, all the trues to ones. So you can just sum it. 20 questions, starting at 3. Data table, column cell. That's not right. Can't always be 1. And we know for a fact that the first one's 2. So what is going on here? Let's just do this a minute. Okay, they've got none. 6, 7, 8. Okay. Okay, and we're just going to do if that equals that, none, otherwise however many are in there. Let's see if this works now. Not quite sure what went wrong before. That looks better. On 260 points. 290 points. Okay, I don't think that's right then. What is going on here then? How many friends do they have in common? How many friends do they have combined? I haven't changed this, have I? Haha. Silly, silly boy. That should be like that. And then that is our sets of answers. There we go. Always check your work. Right. Let's see level 4 then. Level 4 was simply how many friends they have in common combined. So that's pretty easy to do. We just need to change this to... See, I'm remembering to change them this time. Change this to this. Change this to this. There we go, Aaron and Betty. His friend. Counting themselves without double counting friends. So this just needs to be an or this time. There we go, 18. 18. Just whack that in there. What are the bonuses? That's this weird thing which doesn't come into number 5 anyway. So let's make it a level 5. Okay, so for this one we were just looking at whether it was a friend with either of them, whereas this one it was a friend with one of them, and this gets rid of this little duplication thing where you're counting people more than once. Number 5 then, when someone makes a post, all their friends see it and all of their close friends' friends see it. Okay. So we only have one friend, one person, and that person, I'm assuming it's Aaron in this one as well. Yep, it is. Okay, so we get Aaron's friends. So his friend, that's just simply that now. And then his close friend is simply this. There we go. So we've got our close friend. Okay. So we're going to pull this here. And we're going to get 50 rows because this could be any one of the 50 friends. I'm going to insert a column there. Okay, and now we are going to filter Aaron's list of friends by whether or not they are Aaron's friend, and we're going to transpose that down. Even better, we can just take this, and now we just want to choose the rows of this, which equal this. Let's make this instead. Okie dokie. 13 minutes to go. Oh, back to time. So this is simply are any of these not equal to 0 once you filtered out the blanks, because there's a whole bunch of blanks in there. We can also do here we go. This is like what we did before. So count that if it's that. Okay, so count if it's either of those, and that's greater than 0. Okay. How many of these do we need? AZ. They're all true. This isn't right. This should be based on close friends. There we go. Okay, and now we can just do our sum of this. It's 25, and then we need to make sure that does self C. So that is simply looking up our person's name in the list of names and seeing if it's true, and then the answer is that. Let's be fancy, let's do this. There we go. Okay, so what this is doing then, this is saying for Aaron, this is Aaron's list of friends, this is whether or not they are a friend, this is whether they're a close friend, so this is Aaron's list of friends again, this is the identifiers of the close friend. Because this is a dynamic array, we can feed that straight into our choose rows to get the rows based on that number, and then it just looks in all of these columns, assumes that you could be close friends with everybody. We might have some issues here if this is empty. Yeah, if that's empty, we'll have some issues. So let's put that as 0. Oops. Let's put a 0 here. So if it's empty, it's 0. And then if that is 0, then it's blank. Otherwise, we do what we're doing. Just in case someone has no close friends. There are 30 questions on this one. Okay. Oh, 10 minutes left. Making good time. Still got 2 bonuses to go. There we go. And now, what are the bonuses? Who would have their post seen by the smallest number of people? That's easy. We just need a list of people. This. And this time, instead of changing the index, we just change the person 1. No, that didn't work. There we go. So then we want to filter this list based on this equals the minimum value of this. Rebecca. So Rebecca has the smallest reach. And then 8 minutes for this distinct triangles question. Okay. Friend 1, Aaron. Friend 2, Betty. So what we're going to do for this then, we are going to get this. Okay. Okay, so this is set up like before. Just going to get a list of friends through. Using these indexes. Is any friend self? Because we don't want it when they're counting themselves. So we'll check for that, or check for that. Is friends with both. Okay, so we want this to be false. Let's just make the whole thing into a not, so that we want it to be true, because trues are easier to deal with. It's friends with both, so that's just going to be simple. That's not 0, and that's not 0. There we go. Cool, so that should only be false for those two, that's fine. Oh, that's not right. There we go. Whoops. Let's see who's friends with both. Let's see if we can find one. There we go, Henry, so that's true. Use equals. Are both of these things true? That's why I wanted them both to be true when we want them. Okay, we're going to get some duplication if we're not careful. So I can think, so we could just do a really simple, if that's true, then we concatenate the three of them. But that's going to give us some non-unique friends. That's going to give us non-unique friends. So let's do, if that's true, we need to sort them. So we can do a text join, it's one of our new functions, using a semicolon, tell it to ignore empties, and we want to do a sorted version of a fee stack of those two, locked, and that one not locked, and if not, we want it to be blank. Is that behaving as I want it to? Aaron, Betty, Henry, but they will be, but if we put this to Henry, will we still get Aaron, Betty, Henry? We will. Perfect. So we're going to need a two-way data table. Plenty of time, 4 minutes left. And that's simply this. It's not simply that, that's just that one. We want the full list. So that's going to be, we can use text join again. So the thing with text join, if we use a different delimiter this time, if we use 1 or true, that's ignore empty. So that means that it will ignore all of these empty ones. It does not care about the empty ones, and it will only join these. And I think if there are no matches, it will just be nice and clean as well. It'll just be a blank. So now, oh, is this going to be too slow? This might be too slow. But let's try it anyway. Data table. Our row is Henry and our column is Betty. Doesn't really matter which way around it is. That wasn't too bad. Okay. And now if we join all of these, what did we use? We use a slash. If we join all of these, I can see a Henry Zoe Zoe there. I don't want a Henry Zoe Zoe. Okay, right. Not quite sure why that's not. Is that coming from Zoe Zoe? Okay, let's just do this. not. Then we can throw it into our AND condition. Oh, that broke something. There we go. Checks join. Oh, it's going to be tight. All of these. There's an error in there somewhere. Gonna run out of time, not gonna get this bonus. That's fine. We were very close though. Okay. Out of time. How did we do? 1:105. How close are we to getting this final bonus? Let's just see this through. So we're going to filter this by it's not equal to that. And then we're going to text join the whole thing. I don't know why it errors. Is it just too long? So we're going to filter this. By not being blank. We're going to join all of those. It's still giving me calc. I don't know why it's giving me calc. It must be there's too many of them. Let's do it the other way. Let's do text split. This. By this. Column F. And we'll take this whole thing into a row. There's our widest point. There's our widest point at the minute. Again, pick out the blanks, and then we want the unique version of that. $15.94. No, wasn't right. Okay. Let's unhide that. Not sure where that went wrong. Let's have a look in a minute. Let's have a look though. If we got 1105, I think that means we got everything right, which is great. Good to see. And that means if we looked at last year, this was the afternoon session, so Paul Dent at time number 8 and Kenneth Wang both managed that, as did Joseph, who wrote the maze case that we did before. Brittany Deaton, is she this year's wild card? I think she's the only person to have got full points on that qualifier. Really annoyingly, I was really close to getting full points, but I got an entire section wrong because I didn't read the question and it said product, not sum. Little idiotic move there, but it looks like there weren't anyone getting that final bonus, and also jam in it. There we go. Michael Holmes, he must have got that final bonus then and made a couple of other errors, because I don't see how else you would have got 1099. Oh, good. Yeah, he somehow got one of these ones wrong. Interesting. How many are there out of interest? Shall we have a look? 107. Yeah, I thought that was way too big. Way too big. How could we make this work? Do these all look like they're working? So the full list is nothing. This is our full list of Aaron's triangles. Look at Aaron and Charlie. There's 5 there. Shame you can't do a little 3-way what if analysis chart. So let's see. I reckon this is right though. I reckon this is the right approach. Let's just get rid of all this. Let's grab all these again. Those. Okay. Let's filter that by those that aren't blank. And then we can split that out using our slash, and that should give us our triples. There's something wrong in the name sorting maybe. Oh, that's way too long a list. Okay, that doesn't work like that. But we can just pull it down, that's fine. and then we pull all of this. Into a column. Filter it. This time there's zeros, it's fine. Oh, we unique that. It gives me now 1594 again. And we text split each of these. Maybe there's something wrong with the sorting. Okay. So you want a transpose of a sort of a transpose, because you can't use sort, I don't think, on a horizontal array. Really silly, but you can't. Okie dokie. How many triangles of friends are there? They're a triangle if they're all friends with each other. I see what I missed. I see what I missed. I didn't actually check they were friends with each other. That doesn't need to be there. Friends with each other. And then you just need to look. Oh, it's so silly. You just need to look up person 2 and person 1's friends and check it's not 0. And then add that to the and. Oh, that's so silly. There we go, look at that. Way sparser. We've got all these errors now. We've got all these errors, but we don't need all these errors. We only need to go to... In fact, we can just do this. There we go, watch this magically work now. Didn't check they were friends with each other. 107. Here we go, there's your answer. Oh, there we go, 12 minutes because of a silly error. Alright, that's alright though. That's a good score. Let's just have a really quick run through what we did. So we worked out how many friends they've got, and then we worked out the level 1 bonus, which is close friends count as 3 friends, so that gave us the answer to this and to this. Then it was the friends that came first in the alphabet. Nice and simple, you just filter the friends and take the number of the first friend because they're already in alphabetical order. How many friends do they have in common? That was, are they friends with both of them? How many friends do they have combined without double counting? Well, that's just changing this from an and to an or. Nice and easy. Level 5 was a bit more complicated. The way we went around it was we took their friends and then the friends of all their close friends, assumed that they could have everyone as a close friend, so that was this. This gives us how many people saw it, and then we check if they are seeing it themselves reshared, because that doesn't count towards our number, and so we take that away if that's the case. This is broken now. This was working, but this is broken because we've changed this to be non-reactive, not relying on this. And that was so that we could do this, which was our second bonus. This was now feeding in every single name, as opposed to the 30 names that we fed in already. To find you had the smallest reach, which was Rebecca. Yeah, and then this bonus 3, which causes so many hassles, and we nearly got there in the time, other than the fact I missed something so basic that it added an extra 12 minutes on. But what we're doing here is we are taking the 2 friends by name, looking up their friends, checking if either of them is themselves, checking that they're not both the same person, and checking that they are in fact friends with each other. That's the bit we missed. And if all those things are true, then we concatenate them into, let's get one that we can see. That didn't help. Who are 2 people that are friends with each other? It's just being slow because this data table, because it's a bigger data table. So that creates a nice little sorted list of the 3 names, so that they are unique. So they're not unique rather, so that the order doesn't matter. It joins them using this semicolon, and then for each of these groups of 3, we then join that by a slash, using this true value here, which tells it that if a cell is empty, don't include it. Then we have this massive data table here, which just pulls in this value for each pair of friends. Pull this out into a column, filter out the blanks, split them out where they've got more than 1, and then pull that whole thing into a column, filter out the blanks of that, and then filter it down to unique. And you don't need these after all. And our unique, as you can see, has 107 friends. So nearly full marks. Again, missing something obvious, but I think that puts us in good stead for facing against people next time, because people weren't getting full marks. You've got to watch out on that round 2. Jared was getting full marks. Was anyone else? No, so only him to worry about. Oh wow, yeah, he's well above and beyond everyone else last year in round 2, so we'll have a look at that one next and see how we get on. But yeah, other than that, quite happy with that as a result. It's come in at 48 minutes this time rather than an hour. So yeah, so we'll try again with another one in a day or 2. Excellent. Thanks for joining us. Bye for now.